So these are the apparatus to measure the critical angle even for the experiment of total internal reflection. But first we have to know about these two terms: what is total internal reflection, even what is critical angle. This topic covers total internal reflection. So actually, what is total internal reflection? When light falls on the surface of a lighter medium from denser medium at an angle of incidence greater than critical angle, then the light does not refracts. It rather reflects in the self medium. This type of reflection is called total internal reflection. Look at the first diagram. In this diagram, the light simply refracted. Actually, this is water and this one is air. So light travels from water to air. That means denser medium to the lighter medium, and light is refracted. So this is angle of incidence and this one is angle of refraction. But what about the second one? In the second diagram, the angle of incidence is equal to the critical angle. So light simply refracted at an angle of 90 degree. So at critical angle, refracted angle is, or angle of refraction, that one is 90 degree. But when angle of incidence increases in here, light is not refracted. Light simply reflected to the first medium. Okay, so when the angle of incidence is greater than the critical angle, light simply reflected to the first medium. So this phenomenon actually known as total internal reflection. What is critical angle? Critical angle is an incident angle at which the incident ray is refracted and the refracted angle is equal to 90 degree in condition that the light falls on the surface of a lighter medium from denser medium. Look at this simulation. In here, light travels from water to the air. That means light travels from the denser medium to the lighter medium. So what is happening? Now the angle of incidence is exactly 0 degree. So I am increasing the angle of incidence. Look at the example carefully. So light refracted. So in here, look at this, the light simply bending. It's refracted and some of the light reflected to the first medium. So when the angle of incidence increases continuously, what is happening? At a certain level, look at this, no light is refracted to the second medium. All of the light bounces back to the first medium. So when this angle of refraction is equal to the 90 degree, in that case angle of, so for this experiment I just needed this apparatus. So this one is used to measure the angle of refraction as well as the angle of incidence. Okay, now I have to fill it with water to make a denser medium. Actually light will be refracted from water to the air, denser medium to the lighter medium. So now look at this carefully. The light simply pass. Okay, the angle of incidence is 0, even angle of refraction there is 0. So I'm trying to increase the angle of incidence. Okay, look at this, light refracted. light refracted, even light refracted, even in this angle light is refracted. Okay, some of the light is started to reflected, some of the light is already started to reflected, and at this angle, look at this, most of the light is reflected, and this is greater than critical angle. Okay, look at this, this is close to critical angle. Again, this is close to critical angle, and when the angle of incidence is more than critical angle, the light is simply refracted. This angle is greater than the critical angle because all of the light is simply reflected to the first medium, to the water medium. So this is more than the critical angle. This one is like, look at this, this is almost the critical angle, and when it increases the angle of refraction, all of the light simply bounces back to the first medium or reflected back to the first medium. So this angle of incidence is greater than the critical angle.